What this means is that the number of rows and the number of columns present in the image of the electron means that if the pixel size decreases, the resolution decreases. Therefore, pixel size is a significant factor that affects resolution. We previously discussed the next criterion related to sampling frequency, which states that your sampling frequency must be twice or greater than the maximum frequency present in your image. You surely remember this criterion. There is a relationship between maximum frequency, pixel size, and pixel size. The maximum frequency is considered equal to 1 divided by 2 of the pixel size. What does this mean? It means that the larger your pixel size, the lower the maximum frequency you can detect. Therefore, you need to keep your pixel size very small in order to detect high frequencies in the objects present, such as the line pairs we discussed. The smaller your pixel size, the better. Everything you can see a lot means it exists in full. This is the relationship that connects what is higher or lower. So, if you want to enlarge, do you want to see the smaller details and the relationship is inverse? Do you want to enlarge? Do you want to see high resolution? That means you want to see a high resolution with smaller pixel size, or is it an inverse relationship? Of course, Z sensitivity, or when you talk about the level of resolution in Z, is definitely affected by slice width, as well as the detector size and the raw data itself. The larger the size, the lower the resolution. The same idea applies to overlapping slices. Your pitch, as you move in the Z direction, is important. Remember we said that if the pitch is less than 1, there will be overlapping in the data, resulting in more resolution. Therefore, your resolution in the Z direction will be affected by the pitch. The same concept applies to the focal spot, which will also impact your Z resolution. In fact, Z resolution is crucial for 3D imaging because when you take a 3D image, you are capturing an image in the Z dimension. Thus, you want to maintain a high level of resolution in the Z dimension, which is very important in determining the quality of your 3D image. There is a topic called slice thickness. The detector width determines your slice thickness. As we mentioned, if I have 1 millimeter, that is the minimum slice thickness for you, but the reconstruction slice thickness can be 4, 5, or whatever. The more you reduce slice thickness, the more noise increases, and the resolution increases as well. So, does the partial volume increase or decrease? The partial volume decreases. Of course, we talked about this partial volume issue that you have if the detector width is... This is your specific situation, and there are 2 positions that come in this way, and both positions fall on the same detector width. Consequently, it takes the signal and performs averaging from this position and that position. Therefore, in this case, it cannot perform discrimination between them. So what is the solution? The solution is that if I have a large thickness, for example, if I assume that my detector sees them as 2, but I have increased the reconstruction slice thickness, we will now talk about reconstruction slice thickness. The reconstruction slice thickness will take these 2 objects and combine them, resulting in an image where I cannot discriminate between the 2 objects. So the solution is to reduce the thickness so that you can see the slice that contains 1 and the next slice that contains the other. This reduction helps you decrease and improve the situation, but it will increase the amount of data you have. Here, there are large slice thicknesses and small slice thicknesses. This will reduce the image noise and details. You will be able to obtain fewer images when you cut lines with large slice thicknesses. You will get fewer images, meaning the number of images available will be low because you have to increase your slice thickness. Conversely, if you reduce the slice thickness, you will increase the details but will obtain more slices. For example, there is a difference between 5 metraj and 1.2 metraj. The difference in image quality, details, noise, and resolution between the two images is very clear. Also, at the level of the coronal or reconstructed image in the coronal and sagittal views, it is always preferable to increase the axial slice. For example, in the abdomen up to 7 meters, and you will see an image in the reconstruction. It is better not to exceed 4 meters. Beyond that, you will find the image very smooth and very blurred, and you will lose your details, especially in the coronal and sagittal views. So always consider the slice thickness used to give you optimum resolution. As for the interval, there is always something called the interval. What is the interval? Does anyone have it? Does anyone have it? We always hear the word interval or gap. Slice thickness. Take a slice thickness of 5 millimeters and an interval of 5 millimeters. The gap between the slices is not the gap between the slices. The gap or interval is the distance from the center of one slice to the center of another slice. So, I currently have two slices like this, one next to the other. The distance from the center of this slice is the gap or the interval, not the distance in between. So, if I take an image with a thickness of 5 millimeters and an interval of 5 millimeters, that means there is a gap between the slices of 5 millimeters. Why? Because I have 5 next to 5. The distance from the center of this one is 2.5, and the distance from the center of that one is 2.5. So that makes my 5 millimeter me. All right. So the interval is the distance from the center of one slice to the center of the next slice. If I set my interval to 0.5 millimeter, and I say this slice is 1 millimeter, and the next slice is also 1 millimeter, will there be overlap or not? In this case, there will be overlap between the slices. In this case, there will be overlap. If I say from this half to that half, then in this case, I will have 0.5 millimeter of overlapping. Now, if I say that my slice thickness is 5 millimeters and the gap is 7 millimeters, so I have 2.5 from this and 2.5 from that. How much do I have? 2 millimeters. So I have 2 millimeters with missing data. Right? Is that correct, doctors? If I say that the thickness is 5 millimeters and the interval is 7 millimeters, what does that mean? It means that this is 5 millimeters and the section after it is also 5 millimeters. Now let's calculate. We said the distance from the midpoint. So from the midpoint of this section, how much is here and how much is there, doctor? 2.5 here and how much here? So what is the gap? In this case, it is 2 millimeters. Therefore, if the interval or gap is greater than the difference when subtracting the two, that difference is the gap, or that is the data loss. Okay? If the interval is less than the difference when subtracting the two, then that difference is what lies between them. Is it okay or usual? Noise and the types of noise you have. There are many types of noise, but here 3 types are mentioned. There is noise that is related to the number of photons, which we discussed before, and we said that as the number of photons increases, statistically, there is something called quantum noise, and there is something called relative noise. We said that relative noise is inversely related to the number of photons, but quantum noise increases with the increase in the number of photons, and we explained this with an example before. Electronic noise is related to electronics involving wires, connections, and resistors in electrical components. It creates noise or causes distortion in the existing signal. Additionally, there is noise associated with the reconstruction process of image formation. Noise always affects the value of the Hounsfield unit, impacting contrast resolution and either reducing or increasing the uncertainty present in the Hounsfield unit of the image. As we mentioned before, noise is represented by standard deviation. When you want to measure the water phantom, you take a region of interest and calculate the standard deviation, which is the square root of the mean counts or the mean Hounsfield unit of that region of interest. Here, of course, as we mentioned, we have stochastic noise, or the primary noise we talked about, which is quantum noise related to the number of photons detected by the detector here. According to these ranges, you can see the number of photons detected by the detector. Whenever I have 1,000 photons detected, their model will be around 31, whereas if you have 100, you will find that the noise detected is 31 here with 1,000. This is the quantum noise, not the relative noise. The relative noise we mentioned earlier, if you remember, was the standard deviation over n, which is relative noise. Well, as we said, the noise here is talking about relative noise, which has an inverse relationship with the square root of the number of photons. Of course, noise decreases if you change the milliampere, increase it, or increase the rotation time, or increase the slide thickness. All these factors, even the kV for you, should be considered. It works on the quantity of X-rays and also reduces the noise present, increasing the number of photons, increasing tube current, increasing rotation time, or increasing slice thickness, all contribute to a reduction in the noise present. In this segment, we are proudly and enthusiastically presenting the latest and most comprehensive update time, which is crucial for our ongoing project and future development. If the meaning of cauterization increases, what does it mean? It means there is something called cauterization and something else called if. You remember. We talked about this and said, it is what moves what is inside to heat it up and produce a larger quantity at the density. Right. All right. If the filament voltage increases, then you have essentially increased the number of electrons that are produced. Now, this number of electrons will basically increase the number of photons that will be emitted. So you have also increased the number of photons in the end. Essentially, in essence, he is talking about this. Oh, that means you are the one who is responsible for this situation, the one who has been involved from the very beginning. It's quite surprising, isn't it? You, of all people, have been at the center of this entire scenario, playing a crucial role in how everything has unfolded. It's almost as if the universe has conspired to place you in this pivotal position, guiding the events to this very moment. So, when I It makes it so that you have 4 photons, and then it becomes 16. Just like that, simply put. Let's skip the A, so we don't confuse it with the 4 becoming 16. Now, noise is one of the effects that also influences the existing contrast. As we discussed earlier, you have 2 objects. One is black and the other is white. If there is noise present, it will reduce the amount of contrast between the objects. Other factors that affect this, which are also related to noise, are mentioned here as factors influencing contrast. He talks about how higher noise will obscure any contrast between objects. Higher tube current reduces noise in the image. Naturally, the tube current, the electric current flowing through the tube, is what I'm referring to. I mentioned there is filament current and tube current. It's natural to see the dignity of the electric current pilot that I'm talking about. I mentioned in the film that you have current, and in the tube there is current. The current tube refers to the current that represents the movement of electrons, specifically how many electrons pass from the cathode to the anode. Higher current means a higher number of photons, which relates to the noise present in the image. The tissue properties associated with the tissues affect the attenuation. For example, if I have a focal lesion in the liver, there is a low difference in the attenuation properties between the focal lesion and the liver as a soft tissue. In this case, this also affects the contrast and the contrast resolution in the image. Higher beam energy, meaning higher kV. If you increase the kV, it will reduce the contrast. We have discussed before that increasing the kV increases the penetration power and reduces the contrast between the objects. The use of contrast media is supposed to enhance the contrast in the image. So, are you tired of the CT artifacts? Okay. That's fine, no problem. All right, let's talk tomorrow, God willing, about artifacts and dosimetry. Hopefully, we'll finish the section on the 60. God willing, the time for me is 1:15. Well, that's fine, no problem.